morning everybody. So in this class let us solve one more problem on simultaneous differential equations. So the problem is solve the system of differential equations. The differential equations are given as dx by dt plus 2x minus 3y equal to t, then dy by dt minus 3x plus 2y equal to e raised to 2t. So this is equation number 1 and this is equation number 2. Okay, so next we find the solution for these equations. So now in this equation let us denote. Okay, let d by dt is equal to capital D. Okay, so then this equation becomes dx plus 2x minus 3y equal to t, and similarly dy minus 3x plus 2y is equal to e raised to 2t. Okay, so in this case, in this taking x common, and here also from this and this taking y common, right? So this implies d plus 2 into x minus 3y equal to t. Next, the second equation taking y common, so we get d plus 2 into y minus 3x equal to e raised to 2t, equal to e raised to 2t. Okay, so now to eliminate, we have to eliminate one of the unknown. Okay, we have to eliminate one of the unknown. So let us eliminate x. Okay, so to eliminate x, we have to make the coefficients of x in both the equations the same, right? So here d plus 2 is multiplied with x, and here 3 is multiplied with x. So we have to make the coefficient same by multiplying with a suitable variable or quantity. So for example, multiply this equation by 3, multiply this equation by 3, and multiply this equation by d plus 2, right? So when we multiply this by 3, then the equation becomes 3 into d plus 2x minus 3 3s are 9y, next 3t. Okay, next the second equation I multiply with d plus 2, so this is d plus 2 whole square y minus 3 into d plus 2 x, which is equal to, here I have to multiply with d plus 2 e raised to 2t. So now see here, the coefficient of here x is 3 into d plus 2, the coefficient of x here is also 3 into d plus 2, so both are same now. Next is add these two, this will cancel each other. Okay, and we obtain d plus 2 whole square y minus 9y is equal to, okay, is equal to 3t, then plus d plus 2. So operate this d plus 2 on e raised to 2t. So d means differentiation. So d of e raised to 2t means 2 into e raised to 2t. Next 2 into e raised to 2t. Okay, so that is d plus 2 whole square into y minus 9y is equal to 3t plus 2 e raised to 2t, 2 e raised to 2t is equal to 4 e raised to 2t, 4 e raised to 2t. Okay, again in this we take y common, so d plus 2 whole square minus 9 y is equal to 3t plus 4 into e raised to 2t. Now expand this, d square plus 4 plus a plus b whole square, a square plus b square plus 2ab. So 4d minus 9 into y 3t 4 e raised to 2t, or this is equal to d square 4 minus 9 minus 5 d square plus 4d minus 5 into y equal to 3t 4 e raised to 2t. So now auxiliary equation is m square plus 4m minus 5 equal to 0. Now solve this equation. We will get m plus 5 into m minus 1 equal to 0, or m is equal to minus 5 and m is equal to plus 1. So therefore general solution is equal to c1 e raised to minus 5t plus c2 e raised to t. So this is general solution we obtain. Next we find particular integral. Pi is equal to, so pi means 1 divided by d square plus 4d minus 5 of this term. Okay, this term we write here 3t plus 4 e raised to 2t. Okay, so now observe that here, to find out the particular integral, here we have two different functions. So one is algebraic function, that is 3t, and here this is an exponential function. So here we apply the technique of algebraic function, means we have to bring this in the form of 1 plus d and bring in the numerator and expand it, and here it is e raised to exponential rule we have to apply. So directly you substitute d as equal to 2, d as equal to 2. Okay, so now this is equal to, okay, so therefore particular integral is equal to 1 divided by d square plus 4d minus 5 into 3t plus 1 divided by d square plus 4d minus 5 into 4 e raised to 2t. So now here, now 3 is constant, you take that out. 1 divided by, here the constant term is taken out. Here the constant is minus 5. So we take minus 5 common from this whole term. So we get 1 minus of d square plus 4d divided by 5. Then this is t, then plus, and here 4 divided by, directly apply the rule, d is equal to, means you have to replace by a, that is 2. So means it is 2 square means 4, then 4 into 2 8, then minus 5, then e raised to 2t as it is. So this is equal to, now this minus 3 by 5 I will write as it is. Now bring this term in the numerator, which is 1 minus d square plus 4d divided by 5, which is to be operated on t. Then simplify this, 4 divided by 8 plus 4, 12, 12 minus 5, that is 7 e raised to 2t, or minus 3 by 5 divided by, now expand, this is raised to minus 1, sorry, it is plus 1 when it comes to numerator, then it becomes minus 1. So now it is of the form 1 minus x whole raised to minus 1. So you know that 1 minus x whole raised to minus 1 can be expanded as 1 plus x square plus x cube and so on. The same technique we here expand this. So first 1, now this is x, 1 plus x, d square plus 4d divided by 4, 1 plus x. Okay, then x square. So no need to write further terms because here the t has the power 1. The power of t is 1. Okay. Now in this case, we have to consider only those derivative, or we have to consider only those terms of d whose power is less than or equal to the power of t. Correct? Suppose if d cube is there, suppose that if d cube means it is power, d cube means it is a differential of order third order, and t has power 1. So if you differentiate t up to third order, then it becomes 0. Okay, so therefore we have to consider only those powers of d whose power is less than or equal to the power of t. Okay, less than or equal to power of t, then only we get the terms, otherwise the terms becomes 0. Okay, so therefore I don't take the next terms, so raised to 1, then which is to be operated on t, then plus this term I will write as it is, 4 by 7 e raised to 2. Okay, so after this we will get minus 3 by 5, then operate on this, so 1 into t, then d square by, this can be separated as d square by 5 plus 4d by 5, and which is to be operated on t plus 4 by 7 e raised to 2t, 4 by 7 e raised to 2t, which is equal to minus 3 by 5. Now t is equal plus, now see here d square of t, so it is power of this d is more than the power of t. The t is having the power only 1, so the power of d is 2, means it is more than the power of t, so therefore automatically its differentiation becomes 0. So d square, if you differentiate t 2 times, you will get 0. So here the first term d square of t is equal to 0. Next, this is 4 by 5 d of t, it's equal to 1, then plus this is 4 by 7 e raised to 2t, or minus 3 by 5t, then plus 4 by 5 into minus 3 by 5 into minus 3 by 5, then plus 4 by 7 e raised to 2t, or minus 3 by 5t minus 12 by 25 plus 4 by 7 e raised to 2t. Okay, this is the particular integral we obtain. Okay, so now therefore the solution is, so y is equal to, the solution we obtain y as general solution plus particular integral, or general solution is c1 e raised to t plus c2 e raised to minus 5t, then plus particular integral, this is minus 3 by 5t minus 12 by 25, then plus 4 by 7 e raised to 2t, e raised to 2t. So this is the general solution, that is y. So next we have to determine, we have to find x also, we have to find x also. So for that we consider equation 2. Okay, consider the equation 2. So to find y, to find x, consider equation 2. So what is equation 2? It is dy by dt minus 3x plus 2y equal to e raised to 2t. So this is equation 2. Okay, now already we have y value. So therefore, from this equation we calculate x expression. So that is 3x is equal to, bring this 3x to RHS and send this e raised to 2t here. So which gives 3x is equal to dy by dt then plus 2y minus e raised to 2t, or x is equal to 1 by 3 into bracket dy by dt plus 2y minus e raised to 2t. Okay, so now we have y value. This is a y value. Now substitute this y value here. So substituting y value here means you have to find the derivative dy by dt. Okay, so dy by dt. So that is okay, so therefore x is equal to 1 by 3 into bracket d by dt of y value. So y is c1 e raised to t plus c2 e raised to minus 5t, then minus 3 by 5t minus 12 by 25 plus 4 by 7 e raised to 2t. So this is y. Then plus 2y. So y value already we have. So y is again c1 e raised to t plus c2 e raised to minus 5t minus 3 by 5t minus 12 by 25 plus 4 by 7 e raised to t, 2t, close the bracket. Okay, so 1 by 3 plus 2y, and one more term it is minus e raised to 2t. Last term is minus e raised to 2t. So this is the last term. So now simplify this, which is gives x is equal to so this is 1 by 3, close the bracket. Now d by dt of c1 e raised to t. So c1 is constant, differentiation of e raised to t is e raised to t. Then c2 is constant, differentiation of e raised to minus 5t is minus 5 into e raised to minus 5t. Then minus 3 by 5 constant, d by dt of t is 1. Next, minus differentiation of 12 by 35, it is constant, 0. Next, its differentiation is 8 by 7 e raised to 2t. Okay, then plus 2c1 e raised to t plus 2c2 e raised to minus 5t, then minus 3t divided by 5, then minus 12 by 25 plus 4 by 7 e raised to 2t. So it is 8, and here 2 to the 24, 24 it is, and this is 2 into 3, 6. We have to multiply this 2 with every term. Okay, then 6, then this is correct. Then last minus 2 into e raised minus e raised to 2t, minus e raised to 2t. Okay, so this is your x value. So you can take here e raised to t as common, and here e raised to minus 5t, e raised to minus 5t common here, and similarly here you can take minus 60. So you can take and you can simplify further also. So with this I conclude this class and continue in the next class. Thank you.